Mechanical Training World channel. In today's video, we will discuss about UG-37, that is reinforcement requirement for opening in shells and formed heads. So, this is the second lecture of UG-37 guys. Previously, we discussed about part A, that is core concepts and fundamentals behind the UG-37. So, today we will discuss about reinforcement calculations, required area for compensation. So what is the required area for compensation of opening guys? We know that we provide openings for different purposes. If we provide openings means we need to remove some materials which will create strength loss in the material or shell guys. In the figure you can see that this is the diameter of the opening and this is the required thickness and this is the design thickness guys. This is the design thickness and this is the required thickness and this is the nominal thickness. I hope you are understanding. So what is the area lost? First we need to calculate area lost. So how much material we lost here due to opening. So if you find this is the required area for compensating the material, right? So area lost is equal to D into T. We know that D is nothing but the diameter of the opening. So this is the diameter of the opening guys. So T means what? Which thickness we need to consider? For example, if we assume required thickness is 12, so this is our required thickness is 12.5. So but here we are adding some corrosion allowances, right? 3 mm. So total design thickness is equal to TD. Design thickness is equal to 15.5 mm, right? This 12.5 plus 3, 15.5. But this 15.5 will not available in market, right? So that's why we go for 16 mm. So next possible available thickness material. Okay. So this is the nominal thickness T. This is the nominal thickness, guys. So here my question is, what is the correct value of T? So which T we need to consider here? Either T or TD or T. So the answer for this question is required thickness, guys. We need to consider required thickness, that is 12.5 mm only in this formula. So area lost is equal to D into required thickness. So this calculation is based on engineering judgment only. It does not involve any code, guys. So now let us look at the code. So what is the required area as per the code, guys? What is the required area of compensation as per UG-37? So if you go to code or if you open the code and you will find this formula in UG-37. That is A is equal to D into TR into F plus 2 into Tn into TR into F into 1 minus FR1. So here we know D is the finished diameter of the opening. I already told you. And TR is the required thickness of the shell. And Tn is the nozzle wall thickness here. This is the nozzle wall thickness and this is the required thickness of shell. And what is FR1? We use nozzles, right? So sometimes the nozzle material and the shell material may be different. So at that case, the both nozzle and the shell strengths are different. Allowable strengths are different according to their material. So this is the ratio. This is the ratio of nozzle allowable stress to shell allowable stress. So this is what FR1. And what is F? So F is the correction factor, guys. Now my question is, why code formula looks completely different? We already discussed our engineering judgment formula in before slide, right? But here the code formula is completely different. If you look into code formula, this is completely different. Previously, only these two parameters are there. But why these all parameters come into picture in the code? So let's try to understand this formula first. Then you can understand much better. So first we'll take certain nozzles. So this is the shell, this is the shell, and this is the nozzle. So in this figure, what will be the value of D? In this figure, what will be the value of D? As per our engineering judgment calculation, we consider D as the diameter of the opening, right? Not the nozzle inside diameter. But as per code, D is the finished diameter of the opening. So code told that finished diameter. What does it mean? So if you see in certain nozzles, this is the finished diameter of the opening. Previously we talked about opening diameter means this one, right? But the nozzle compensated some of the opening, right? Through this thickness. So finally we have only this much of diameter to compensate, right? So this is our value D. First setting nozzles. I hope you are getting the point. Hence, we can see that some amount of area lost is compensated by the nozzle wall that is inserted, which will also depend on the nozzle material. I already told you it will also depends on nozzle materials. So to consider this, we have a factor that is FR1. So we need to calculate FR1 is equal to allowable stress nozzle by allowable stress for vessel. So if nozzle material and the shell material is same, then our FR1 is equal to 1. So let's try to put this FR1 in the formula, guys. So our area required for compensation is D into TR into F, because here 1 minus 1 is the 0, right? This whole terms comes 0 here. So and finally we got area required is equal to D into TR into F. So now let's try to calculate F. So before that we need to calculate set on nozzles. So in set on nozzles, there is no nozzle coming into the area lost. You can observe here. In set on nozzle, nozzle is above the shell. So there is no area coming into the opening portion. So here our D is the diameter of the opening. There is no point in the considering the nozzle allowable stresses in the formula, right? Here no need to consider that FR1. So here FR1 is equal to 1. So if you put the same thing, you will get the A is equal to D into TR into F. So this is the area required for compensation set on nozzles. So now let's try to find out the F. So understanding the F is very, very important, guys. So as we know that stress act different in different planes of the vessel, right? So this is our vessel. So we know that stress acts differently in different planes. As we saw in UG-27, that the thickness due to circumferential stress and the longitudinal stresses are different. Why? Because due to longitudinal due to different planes, right? Due to different planes, longitudinal planes and circumferential planes. So if we cut the vessel through the longitudinal plane, so this is the vessel axis. So if we cut the vessel through a longitudinal plane, then we can see how the nozzle looks like. So if we cut like this, so this is the cutted portion. So this is the portion we look like this, right? So this is the shell and this is the nozzle. So if we observe from the top side, so how this looks like, guys? So this looks like a circle, right? And I already told you we will keep the openings in different planes. So if, for example, and different angles as well. So this theta is the angle between the nozzle with reference to the longitudinal shell axis. So by using this theta, we will find the value of F, guys. So you can see here, this is the table available in UG-37. So if you open the code book, you will find this table in the UG-37, guys. So this is the angle theta plane. This is the value of F correction factor. That is, if theta is equal to 0, your F is equal to 1. If theta is equal to 90, your F value is 0.5. So this is how you need to calculate F value by using this graph, guys. So this graph will available in code book. That is section 8 division 1 code. So you can refer that one. So now let's try to focus on areas providing reinforcement. So what does it mean, guys? So we know that apart from reinforcement pad, we have other areas that inbuilt providing as a reinforcement. So what are that areas? So in set on nozzles, the diameter of the opening and thickness of nozzles are two key parameters. The required thickness of the nozzle is represented by the orange color, guys. Here you can observe this is the required thickness of the this is the required thickness of the shell, not nozzle. This is shell, guys. So any additional thickness beyond this required thickness will act as a reinforcement area. And you can observe here, this is our nozzle and this is the reinforcement. Okay. So apart from these thicknesses, what are the extra thicknesses available here that will act as a reinforcement? I already told you our required thickness is something is like this. This is our required thickness. But due to this thickness not available in the market, we are ordering more thicknesses, right? Available thickness. So whatever this portion available in the yellow color, that will act as a reinforcement. This is the inbuilt. It will act as a reinforcement, guys. Apart from this reinforcement pad, so we need to minus this if you want to get required area for reinforcement. And also we have shell in shell side. Also we have extra material, right? I mean extra thickness, right? So we need to remove this thickness as well. So this is the thickness, nominal thickness. So if you remove this, so this is our required thickness and this is the opening diameter. I hope you understand. So if you want to required thickness, you need to minus this yellow color portions, yellow color thickness portions. Okay. Now let's see set-in nozzles. So the idea of the nozzle will be the opening diameter. In set-in nozzles, you can observe that the ID will be the inside diameter of the nozzle, not the opening diameter of the nozzle. I already told you. So reinforcement provided by the areas in the set-on type of nozzles will also act as a reinforcement areas in set-in type of nozzles. So whatever we discussed in the before slide, so will applicable here also. That means extra thicknesses in the nozzle and shell area will act as a reinforcement. That means inbuilt reinforcement, and also this thickness also act as a reinforcement. Okay. So and whatever the inside portion of the nozzle also acts as a reinforcement, inbuilt reinforcement. If you want a required area for reinforcement, you need to consider all this. You need to minus this yellow color ones and this inside nozzle area. So I hope you are getting the point, guys. So up to here, this is the required area for the internal pressure case. So what about external pressure case? So let's try to understand this formula. If you open the UG-37D1, if you refer UG-37D1, you will get a formula A is equal to 0.5 into D into TR into F plus 2 into T and TR F into 1 minus FR1. So this is the extra term added here, 0.5. So apart from this, all are same only. Okay. So here F is equal to 1 for external pressure condition. So this F is equal to 1 for external pressure condition. TR is the thickness required for external pressure condition. So this is all about for this video. In next lecture, we will discuss example problem on this UG-37, guys. So if you like the content, please subscribe my channel and click on the bell icon and share to your friends also. They will also get benefited.